Okay, hello. So today we're gonna go ahead and present my three favorite topics from these last semester of psychology. So first is Sigma Freud, then the central nervous system, then we have neurotransmission, which honestly is my personal favorite. Excuse for the camera being so close, Dr. Agnes. Now, to start off with Sigmund Freud, right here, as you can see, he was born in the Czech Republic back in 1856. He was an Austrian neurologist who developed psychoanalysis. His theories of child sexuality, libido, and ego were most influential in the 20th century. Now, as you can see here, this is a picture of him as younger age, of course, as he was just becoming a psychologist. And of course, this is him over in his later years. Now, if we move on to Freud's psychoanalytic theory, it believes that our mental state is made up of two forces called cathesis and anticathesis. Now, cathesis is the abundance of mental energy or in a person or an object. Now, while anticathesis is involved with the ego blocking and the unacceptable needs of id. Now, if you look down here in the that I have here, id basically means instincts, while ego means reality, while superego means morality. Now, if we move on to some more of Freudian's theories here, we move on to Freud was more of a humanistic approach towards human behavior. He believes that the human behavior is based on two major factors, life instincts and death instincts. While life instincts means for need of food, shelter, love, and even sex, while death instincts, Freud believed that everyone has an unconscious wish for death, which honestly completely just scares me to death. I don't think about that normally, but hey, if Freud believes that, then let him believe that. Now, moving on to a more interesting topic here, the central nervous system. Basically, the central nervous system, as you can see here, is made up of the brain and spinal cord. It contains the cerebrum, which is made up of two hemispheres and connected by the corpus callosum. Now, if we move on here to the midbrain, basically the midbrain is made up of the medulla pons and the pons. And its main function is for all involuntary responses. So, for an example of an involuntary response would be, as you can see here, a person touching a heated pan and then moving their hand and saying ouch. That would be an involuntary response, and that's where it all happens, here in the midbrain. And then, of course, the parietal lobe, where the pain is sent to. Now, if we move on to the four lobes of the brain, we got frontal, which is right here. Basically, its main function is for motor cortex, so you're able to move your hands like this. Behavior, learning, and then, of course, any voluntary movement. While the temporal lobe is for language comprehension and emotion. While the parietal, like I said, is for pain. That's where the pain is sent to. And that's where it receives to let you know, ouch, I'm in pain. Move your hand. You better move your hand. Then we have the occipital lobe, which is right over here. And that's basically just your visual cortex. Now, if we move on to neurotransmission basically is just the process of neurotransmitters firing from each neuron to from the presynaptic neuron to the postsynaptic neuron. So basically, what is a neuron? Now, a neuron consists of dendrites, a cell body, and an axon terminal. Now, I don't know if you can see it here in this example that I gave here, but these little branchy parts right here are dendrites, while this little circular part would be the cell body. And all the way over here would be the axon terminal. And of course, these are just myelin sheath here to help it out. Now, like I said, they're known to be a presynaptic neuron and a postsynaptic neuron. Now, how do neurotransmitters fire? Now, neurotransmitters simply, when at its resting point, which would be negative 70 millivolts, positive sodium ions will rush through and cause the neurotransmitters to fire. Now, as you can see here, this would be the presynaptic neuron, which has all the neurotransmitters, and right here is the synaptic cleft. These are all neurotransmitters which are getting sent over to the postsynaptic neuron. I'm not sure if you can really see that clear, but right here, basically, it will be sent over to the postsynaptic neuron, and right here, as you see the little dot fixing into the little receptors right here, that is something known as the key and lock function. Basically, it just fits in just like a key into a lock. Now, if we go over here, bring this over here a little bit so you can see that. When you start here, you're at your resting point. Then you go from your resting point to the depolarization, up to the action potential. Then once you reached your action potential, you can't go any farther than that. It goes back down to repolarization, back down to the hyperpolarization, to the resting potential. Then it just completely restarts and over and over and over again. Now, what happens to any leftover neurotransmitters? Now, to the leftover neurotransmitters, they begin a process called reuptake. Simply, it's just reabsorbed back into its old neuron. Also, there's another, when neurotransmitters break down into enzymes when left in between the synaptic gap, as seen here, they will break down and turn into little enzymes. As you can see here, here's some more of the synaptic cleft a little bit right here, so you can see. But yeah, these are basically just dopamine reuptake inhibitors, as you see here. It's being reuptaked, and here's another example of some of the enzymes being broken down. Definitely neurotransmission, the process, by far, honestly, I think that's my favorite topic. It's really just amazing about how our body can perform all these amazing functions.